See, now we are going to use just the same equation what we used for the least square estimate. I'll use the equation. With that equation, what we are going to do is we are going to estimate some parameters that need to be computed by a maximum likelihood. That is, y is equal to let me beta naught plus beta 1 x 1 plus sigma. Sorry, plus I write it as epsilon. So this is what the equation we are going to take. This is actually a linear regression where we can have it as nx plus c, where error term is also there. I'm adding an additional weight here, beta naught, so that if it goes for a multiple linear regression also, I can take this as beta naught x naught, where x naught will be considered as 1. X naught will be considered as 1. I am assuming here that x naught is also present, but x naught is considered as 1. If there are more number of independent variables x1, x2, x3, x4, I can have that much corresponding beta values and estimate those parameters. Right now, the parameters what I need to estimate here is we need to estimate beta naught, beta 1, and I need to estimate something called the sigma. So now I need to explain you what is the role of the sigma here. The same thing we estimated in the least square estimate also. What is the use of sigma is when I estimate any distribution, I need to categorize both the mean of the distribution as well as the variance of the distribution. So I have here sigma, or I can also go directly with sigma squared. Either I can have the standard deviation, or I can directly have the sigma squared variance. Anything I can take and I can use that for estimation. So these two things are my primary concentrations. These two corresponds to the rates, and this corresponds to the sigma. Right? I assume that it is assumed that the entire distribution for the regression term follows normal distribution. We assume that everything follows a normal distribution. The parameters are normally distributed. Yes, sir. What will be the mean of the normal distribution? I say that the parameters are normally distributed. If the parameters are normally distributed, I can write that sigma epsilon, that is the error, epsilon will be in belonging to the normal distribution function. In normal distribution, we say that mean is always 0. We say for normal distribution, mean is always 0. And if it is uniform normal distribution, I say the variance is only 1. Mean is 0, and so and the standard deviation is 1. Sigma squared is also 1. Sigma is also 1. Right? If then I can call it as a uniform normal distribution. Now, I'm not going to categorize it as uniform normal distribution. Just I saying that they are normally distributed, right? So I can categorize that this epsilon, that is the error, is going to be in normal distribution, that is mean 0 and standard deviation 1, or I can say it is sigma squared. If it is uniformly normal distributed, I can have sigma squared as 1. So this is a consideration what I take. So why this assumption I'm actually taking is I want some equation to represent the entire error value so that I can proceed for the likelihood. Right? Without those distribution, I cannot proceed. I said yesterday, right? I have a huge bowl where I can have red color balls, yellow color balls, black color balls, and I need to find the likelihood of taking yellow color ball or the likelihood of taking black color ball from that whole huge bowl. So what is the likelihood is nothing but how the ball is going to behave with how my selection is going to behave with respect to the colors. And similarly, if I have a sequence of animals and birds, what is that my how my algorithm predicts whether the chosen image is an animal image or a bird image? How my algorithm selects. So those things I need to concentrate. Right. This is what we are actually focused on. And if I was able to make that distribution, I can use either binomial distribution or Poisson distribution or Bernoulli's distribution or normal distribution or any kind of distribution I can use and write the corresponding distribution formula for representing the entire value, right? Now I can represent sigma because I say it is normally distributed. So I take the probability density function of normal distribution. I take that, and using that I will represent my entire error term. So I will write f of, turn that into an equation, f of sigma I. There can be many number of terms when it is multiple linear regression. There can be any number of error values. So I term it as sigma I will be equivalent to. I'm just using the word latex so that equation will be very clear. Instead of writing it in paint, I was feeling comfortable to explain these mathematical terms in word latex. 1 divided by sigma square root of 2. So what? 1 divided by sigma square root of 2 pi. Class line right, this is actually the term. I need to convert this, it is not working. I can use this directly. 1 divided by sigma square root of 2 pi. While here is the remaining part. So this is the term 1 divided by sigma square root of 2 pi into e exponent of. I'm just writing the normal distribution formula, right? The same normal distribution. We have discussed the same as a Gaussian normal distribution in AML itself. Hope you remember that. It is minus 1 divided by 2 epsilon epsilon I minus mu I. Now mu is nothing but mean. I have my mean already ready. My mean is 0. So epsilon I minus 0 divided by sigma squared. Divided by sigma squared. So this is the entire formula for the normal distribution, right? That is 1 by 2 sigma I divided by sigma 1 by 2 epsilon I divided by sigma square. This is actually the normal distribution formula for a regression term. Now I say that my epsilon is going to be normally distributed. So I use this probability density function formula for doing my calculations, right? Now using this representation for sigma, I need to calculate beta naught, beta 1, right? But and the sigma squared also. But in this function, I'm having sigma squared, but there is no representation for beta naught and beta 1. So where that beta naught and beta 1 goes, right? Now remember in the least square estimate, we had epsilon is nice there. We represented epsilon as y minus beta 1 x1. Right? We represent by epsilon as y minus beta 1 x1. Here I am having beta naught and beta 1. So I can represent this epsilon I as epsilon I is equal to yi minus beta naught minus beta 1 x1. I can also represent the y as beta naught and beta 1, right? So in that way I can convert this epsilon I into beta naught and beta 1. Why? Because I need to estimate everything with respect to beta naught and beta 1. But the term here is, here I'm having epsilon, but here I'm having epsilon I. An atomic term is present here. I need to convert this epsilon I into epsilon. So how much epsilon I will be there? There can be any number of epsilon depending upon the likelihood functions. So my likelihood function is nothing but how many number of functions are actually being present and taking the likelihood of that. So what I will do, The likelihood function is nothing but function is if it is epsilon I, then how many number of likelihood function can be there? It's f of epsilon 1 represented is this epsilon. I'm considering that they are independent of each other. The one error value of one parameter will not depend on other error value. All the error values are independent. Using that, I say that this can be represented as a product term where I can actually represent it as product of, I can say I is equal to 0. This I is equal to 0 to n. This I can write here epsilon I. So since it is since all are actually going to be independent, I can just multiply all the epsilon error values and then represent it as a multiplicative term. Now I can get epsilon. So what is the epsilon is multiplication of all the epsilon values becomes on the epsilon value, right? So I can now I know that epsilon can be represented as y minus beta naught minus beta 1 x1. I can represent it epsilon like that. Now this epsilon I can be substituted here, right? Now I can have this as actually equation 1. I can represent this as my equation 1. I just substitute want to take this f of epsilon I into here. I want to represent it here. So my cumulative term will be I want to take all the products and represent it. So how can I take all the products is nothing but I can represent this as a capital F where I can take the product entirely. I can take the product of this entirely, but these terms will not change. These are actually constant terms. 1 by sigma root 2 pi x square root of 2 by x. Everything are same. The change where it will happen is actually with respect to the epsilon alone will be happening. Here also I can write it as minus 1 by 2. Everything are actually same. Instead of this epsilon I have to write it as pi I is equal to 0 to n sigma I. I should write like that. Even the sigma squared I can write like the same because it is 2 I can write the sigma squared slash sigma squared. I can represent it here. Next I need to write this entire term. Yes, this is what the actual equation is going to be. So we have 1 by sigma root 2 pi exponent of minus 1 by 2 sigma squared pi I is equal to 0 to n sigma I. So this is the final equation through which we are going to start our working everything. These our full analysis is going to proceed only with this formula. We are not going to take all the epsilon values. Only these epsilon values I am going to take and start working. Right? Hope the equations are somewhat big. Actually, I missed a square root here. Right? I'll explain one more time first. So you just say me whether you are understanding it or not. When you go for MCQ, everything will be going with respect to the formulas only. So please understand and then say me. And once I will say from first, if you understood, say yes or no. Okay, don't be silent. So the linear regression formula, what I actually take is y is equal to beta naught plus beta 1 x1 plus sigma. So this is the thing. In this, what are the parameters I have to estimate is beta naught, beta 1 and sigma. Why I take sigma? For I need to estimate the error. If I want to estimate error, I have to estimate its mean and its standard deviation. I need to estimate. So I am taking the sigma of the epsilon values. So these are the values I need to estimate, and I make an assumption here. What is my assumption is my parameters of the regression is going to be normally distributed. So if it is normally distributed, what is the thing? So then if it is normally distributed, then my error is going to have mean 0 and sigma square, and my standard deviation will be sigma, and my variance will be sigma squared. And the thing to understand here is, if possibly my distribution is going to be uniform normal distribution, then sigma squared will be 1. My variance also will be 1, standard deviation also will be 1. But we cannot assure that all the time it will be uniformly normally distributed, right? So this is the only assumption we take, and we substitute here in the formula. This formula is nothing but the normal distribution formula. We have binomial distribution, Poisson distribution, Bernoulli distribution. Many distributions are available. You would have studied, right? So I'm just using the normal distribution formula, that is f of x. F of x is nothing but the distribution parameter indicator variable. Here my indicator variable is nothing but the epsilon. So I take f of epsilon of I is equal to 1 by sigma root 2 pi. Uh, this root is for entire 2 pi. Okay, exponent of minus 1 by 2 the xi, instead of xi I put epsilon I minus mu. What is mu? Is 0. For normal distribution we have mean as 0, the whole square divided by sigma square. So this is actually the formula for normal distribution. In this distribution we have a term sigma I, right? We have a term sigma I. So I cannot take sigma I directly. Why? Because I need to convert the sigma I in terms of y, beta naught and beta 1. If I want to convert like that, then what I will do? Epsilon is equal to y minus beta naught minus beta 1 x1. I need to take like that. If I do that, I get a value for epsilon, not epsilon I. So I need to convert all the epsilons into epsilon i's into epsilon. So what I do, I take the likelihood function of all the epsilons from epsilon 1 to epsilon n, assuming that there are n distributions. Okay, n different independent variables are there. For each independent variable, what is the error term I take, and I assure that those error will not depend on each other. If they are not depending on each other, I can just take the product of those functions, that is phi I is equal to 0 to n epsilon I. I just take that. So if I take that, I get the value for epsilon. So that is what I'm doing here. Here it also epsilon I the whole I minus 0 whole square. So it comes here epsilon I the whole square. Okay, I'll do one more time. Okay. So the maximum likelihood estimate. So what is the initial linear regression or a normal regression formula I take is y is equal to beta naught plus beta 1 x1 plus sigma, right? So what is the sigma term?
Error term, sir.
Error term. And this beta naught I take, why? Because I need to model it for multiple linear regression also. This beta naught does not have the x value. So what I do, I take the x value as x naught. The default x naught value will be 1, right? So here also you assume that an x naught is there, and this beta 1 x1 is going to be my the model gradient, right? So the parameters I need to estimate in this equation is beta naught, beta 1, and the error distribution. If I need to explain the distribution of an error or any of an indicator variable or a variable, what I have to take, I need to understand its statistical parameters. What are those? I need to represent their mean as well as the standard deviation. So this mean, I'm assuming that this parameter is going to be normally distribution, right? Because I need to say whether it is any distributed or not. Only when I can take the corresponding distribution formula and start working, right? Hope you have studied in your probability and distributions, right? You will take any wholesome continuous or discrete distribution, and you will be applying Poisson distribution, binomial distribution, uniform random distribution, Bernoulli distribution, normal distribution, uniform random distribution. Many probability distributions are there, right? I'm assuming that the error term is going to be normally distributed. That is the only assumption I'm taking, because only when that assumption is true, I can actually proceed on with any one distribution formula. This normal distribution states that the mean is going to be 0, and standard deviation is going to be my sigma, or variance is going to be my sigma squared, right? So this is the thing. If my distribution is going to give me surely a minimum value, then it will be uniform normally distributed, where the sigma squared will be equal to 1. But in real time case, I cannot assure that uniform normal distribution exists for all the error terms. So I make sigma squared as a variable itself. I don't make it as a constant. But mean I take it as 0. Yes. Next, this is the normal distribution formula. That is f of an indicator variable. F of x is equal to 1 by sigma root 2 pi exponent of minus 1 by 2 x minus mu. Mu is nothing but mean x minus mu the whole square divided by the standard the variance sigma squared. Right. This is what the normal distribution formula. Right. I'm going to take normal distribution for my error parameter. So it is sigma I is equal to 1 by sigma root 2 pi exponent of minus 1 by 2 x sigma I minus 0. Why I put 0 here is I assume it is being normally distributed. So my mean is going to be 0. So sigma I minus 0 the whole square divided by the sigma square. Right. So for epsilon also I'm saying a sigma. Right. So it is epsilon I minus 0 the whole square divided by sigma square. Now I need to estimate beta naught, beta 1 and y. That's what are the sigma I have to estimate. Y is my output variable. But this equation does not have beta naught, it does not have beta 1, it is only having sigma squared. So I need to convert this equation to have parameters beta naught, beta 1. Because the same thing, I don't apply partial derivation 1, for the second partial derivation, what I applied for least square estimate, I'm going to apply here also. But if I want to apply partial derivation with respect to beta naught should be present here, but beta naught itself is not there. So how to make? I need to convert this sigma I into y minus beta naught minus beta 1 x1. But we know that sigma is equal to y minus beta naught minus beta 1 x, not sigma I, that are epsilon I. So I need to convert this epsilon I into a wholesome epsilon. All epsilon values I need to take. So epsilon 1 for the first independent variable, second independent, all, and I am assuming that n independent variables are there. For all the independent variable regression estimates, what is the error I need to take? I say that there are n independent variables, so the error occurred for those independent variables will also be independent, right? That is true, right? If I was estimating y with an independent variable x1, then the error 1 caused by x1 will be the one term. Error 2 caused by another independent x2 is something different. Those error 1 and error 2 will not have same pattern or a common pattern. So error 1 and error 2 are independent. I say that all the errors are independent. So if they are independent, the wholesome value can be calculated by just multiplying all the error terms. Error 1 into error 2 into dot 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 error in. Multiply all the error terms. So I take pi f of sigma I. I need to take product. This pi term represents product. The big sigma represents sum. Pi represents product. So I take this product term into sigma I, right? Now when I take here, I want to multiply everything with respect to sigma, and these terms are constant. 1 by sigma root 2 pi exponent, everything are actually constant. And which point I have actually dealt with the product, then I just substitute that product over here for sigma I, right? So that the entire sigma can be obtained, right? So up to this, I was actually stopping. Now I need to substitute this y values here, right? Now, shall I proceed to the next one? Now, what I'm going to do is take ln on both sides. I'm going to take ln on both sides, right? Now, I represent the ln as f star. I represent the ln as an f star, where ln f is equal to, how to represent the division in log. If a log of 1 by 2 will become what? I'm having 1 divided by sigma square root of 2 pi. So how can I write this? You said log 1 is 0. So log 1 will be there minus, I have another time log, and I have sigma square root of 2 pi. This is nothing but square root of 2 pi. I write here separately like a note. Student, my paint
Yes,
window
sir.
is visible now?
Visible.
Yes.
Yes,
So
sir.
1 by
Visible.
sigma 2 root 2 pi, I write this as, I write another term 1 divided by whole square root of sigma squared 2 pi. Can I write like this, whether both are same or different? Whether both are same or different? sigma squared can be when I take out it becomes sigma square root. So if I want to bring this sigma inside, I take sigma squared, right? That's one thing I actually doing here. So this is clear, right? 1 divided by square root of sigma squared 2 pi. Now if I take log of some values, if I say log of x squared, if I want to take log of x squared or something, what will be the answer if I take log of x squared?
2
I
log x.
take 2 log x. Great. If it is log of if it is 1 by x squared, what I will do? 1 by x squared can be written as x power minus 2. Am I right? 1 by x squared can be written as x power minus 2. Now we forgot about this 1 because log 1 will become 0. Now this particular term, can I write it as sigma squared 2 pi the whole power minus 1 by 2. Can I write like this? This is sigma squared 2 pi whole power minus 1 by 2. So now I write here. Now take log on this. So this will become log 1 minus log. Write the entire term, this entire term. Sigma squared 2 pi the whole power minus 1 by 2. Now say what is log 1? What is log 1? Log 1 is 0. And now say how this minus 1 by 2 I should write. It is in the exponent term. How to write the minus 1 by 2? You said x squared should be as 2 log x, right? A log of x written as 2 log x, you said. How to write this log of sigma squared 2 pi? You say that log x squared can be written as 2 log x. How to write
Minus
log
1 by
of
2 log
sigma
square.
squared 2 pi the whole power minus 1 by 2? Yes, yes, come again.
Minus 1 by 2 log 6 sigma square root 2 pi.
Yes, yes, minus 1 by 2 log sigma squared root 2 pi. Very still, I'm not going to there in the Word document. Small things, sigma squared 2 pi, how I'm writing is represented here. I am to understand here is when I go to the Word document, see here I'm having 1 by sigma root pi, and that is represented here. And the condition to understand here is I'm having a sigma squared over here, having one sigma squared. If log of an exponent, what will happen? The exponent and the log get, am I right or wrong? If I take log of an exponent, the exponent term and the log term will get cancelled and the exponent will become a normal term. Am I right or wrong? Just the exponent term will become a normal term. That's I'll also continue with the exponent term cancellation. So I'll write here log 1 becomes 0. And like Shruti said, I'm going to take the terms as without logs. So I just say 1 by sigma root 2 pi can be written as 1 divided by 2 is taking the 1 by 2 power over here and then putting the entire term whatever we got here. I'm in the paint window, whatever we got here I'm just going to substitute here. Log of sigma squared, I need to convert into equation, sigma squared 2 pi or 2 pi here 2 sigma squared by or 2 pi sigma squared, anything I can write. So this is the thing. So this one is the clear. I will put 0 afterwards here. It starts with minus 1 by 2 log sigma squared 2 pi. Next, coming here, now I have to take when two terms are in multiplication. In log, it becomes plus. So here 1 by sigma root 2 pi in whole power exponent. It is whole power exponent. And when I take this exponent, it will be going for how many times? It will be going for n times. So it is what? It is actually n times I need to take this exponentiation, because the sigma squared is running for a product term, right? So entire term is in product again. Now, how can I take this exponent value separately? That's what we have to identify. Now, you know on term, like when I'm having something like this x1 x2, I'm having something like x1 x2, and when I take log of this, what I have to, how can I represent x1 and x2? Log of x1 f2 can be written as log x1 plus log x2. Am I right or wrong? The same thing I'm writing somewhat differently. I'm writing product of some xi values, product of some xi values. If I take log of this product, how can I write here? If I take
Sum of
product
all
of this,
logs.
shall I convert this into summation of log xi? Can I do this or not?
Yes, sir, we can do.
Yes. So now can you say how this equation, this particular term can be written? This particular term alone, pi of I is equal to 0 to n sigma I square. If I take log for this, what will come?
E power summation log, sir.
Yes, summation of I is equal to 0 to n log summation I, right? Like that it will be coming. Next I'll be
E
working
power
on
will
that.
also come, sir.
Come again?
E power will also come, sir. E power summation of logs because we are taking log on
No,
both
no.
sides.
Yes, I'm not considering this exponent. I'm just considering this particular term alone. This product term alone. This product will now convert into summation, right? That's what I'm actually saying, right? Now I'll convert this summation I is equal to 0 to n sigma I into this like term log x. So that in that way we proceed. Then what I will do is I actually substitute the summation I says, that is sigma I with y minus beta naught minus beta 1 x. That's it. The entire formula will be over. When I convert this sigma I into this particular term, what will happen? These terms will be substituted here. Then using that term, I will take partial differentiation with respect to 1 and partial with respect to beta naught, with respect to beta 1, with respect to sigma. And with that, the entire derivation over. It will come just for a half a page, but need to understand the mathematical background. Once that is done, everything will be easy, right? So just these 4 lines I have taken for this class. These 4 lines I have taken. Next, I'll take a log. Then I will substitute the sigma I with y minus beta naught plus beta y minus beta naught minus beta 1 x1. With that, entire thing goes. Entire thing completes, right?